Today our focus is using the information that we learned on Friday, which was finding the vertical, horizontal asymptotes, and finding any holes and y-intercepts. Putting that information onto these graphs, okay? I'm gonna show you a couple other things that we didn't do on Friday, and we're gonna put it all together and we're gonna graph it. We're gonna sketch a graph. We're just gonna sketch it. It's not gonna be 100% perfect, but we're gonna use a calculator and see how close we are, okay? So, on Friday, we took this, these are called rational functions. We have a fraction with a polynomial on top and a polynomial on the bottom. We talked about vertical asymptotes. Can you tell me, this is already factored for us, where do we have a vertical asymptote? You look at your denominator and you're gonna set it equal to 0. So where is your vertical asymptote?
It would be -1.
X equals -1. You get any vertical asymptote from the bottom. How do you graph x equals -1? Where is x equals -1?
-1 x-axis.
Okay. Now, how about horizontal asymptotes? There's nothing that we're crossing out, so there is no hole. We didn't have to cross any, there's nothing removable. So your horizontal asymptote is you're gonna set the numerator and the denominator equal to 0. I'm sorry, you're going to look at your degree of your numerator, degree of the bottom. If they're the same, your asymptote is y equals 1. Thank you.
Wait, what? Do it again?
You look at the degree of the numerator and the denominator. If they are the same, you take the leading coefficient of the numerator over the leading coefficient of the denominator. So y equals 1 is your horizontal asymptote. Now, a horizontal asymptote is more for the end behavior. You know how you have from negative infinity to positive infinity? It's a weaker asymptote. Your graph can cross a horizontal asymptote, and sometimes it does
Can I ask you a question?
around here, yes.
So did you go up 1 on the y-axis because y equals 1?
Yes. This is the graph of y equals 1, right there.
Okay.
Okay, now, your y-intercept. What does y-intercept mean? What is y-intercept?
It's 1.
It's not 1, but what does y-intercept mean?
For the line
Where it
across
crosses
the
the
y-axis.
Okay, these are all y-intercepts, right?
Yeah.
Can you tell me what this ordered pair is?
1, 2,
What's this point? 0, 2. What's this?
0, 3.
0, 3. What's this?
4,
0,
5,
0,
5,
0,
7,
0, 0, 0. What is the same? Do you hear me saying the same thing over and over again? What? What am I saying?
You were saying 0.
0 when? When am I saying 0?
Next.
Okay, so to find any y-intercept, you set x equal to,
0.
so if I were to put a 0 here and a 0 here, what's left?
2 over 1.
So 2. So this particular function,
So do you always, is x always 0?
always for the y-intercept, always,
Okay.
always. So where is 0, 2? It's right there. Now, in first hour today, a lot of people wanted to go put 0, 2 right here. This is different than the first section that we did. This is not 0, 0. 0, 0 on this is right there. So where is 0, 2? It's right there. Don't do it, or actually 0, 2, and when we did it section 8.2, we made this our new origin. Don't do that on these. So it's right there.
So when we take a test, how are we going to know?
8.2 is it's gonna have, that's gonna be your new x and y axes. But on section 8.3, it's the origin is the origin.
So are we taking it as a whole?
Yes, we're putting them both together. Okay, who had a question? Someone else had their hand up, I think.
I did, how did you get 0, 2 again?
Okay, you guys tell him, how do you get 0, 2?
The x-axis is 0, and then 2 for the y-axis.
You plug, when you're finding the y-intercept, you plug 0 in for x. If I put a 0 here and a 0 here, you have 2 over 1.
Oh, every time or just?
All the time.
Okay.
All the time.
Alright.
Now, not only do you have an x-intercept, or a y-intercept, you have an x-intercept. These are your two x and y-intercepts right here, your roots and your y-intercept.
So for the y-intercept, would it be 0 then? Would it be like flip-flops?
The y-intercept, you already found at 0,
No,
2.
the x, for the,
The
I'm saying
ze-
for the x.
What you do is you set your numerator equal to 0 to find your roots. So if I set x plus 2 equal to 0, what is it? Negative 2. Negative 2. So where is negative 2, 0? Right there.
Can I ask you a question? What was the point of us making this new graph thing if we weren't technically gonna use it?
I'm gonna show you. You're talking about the asymptotes?
Yeah, like I don't see what we,
Okay. What you are going to have is a graph that these are like lines on, think of the expressway, okay? So what is this? This is like a guide. You can't, you're gonna stay in your lane, you're not gonna cross that. Okay, that's what that is. So now, this is where it gets fun. I want you to, this is critical values. The critical values are anywhere in the problem where you get a 0. So at negative 2 and at negative 1.
wait, how did you get that?
You set your numerator and your denominator. So we call these critical values because something's gonna happen at negative 2. Something's gonna happen at negative 1. There's a change, there's gonna be a change in the graph at negative 2 and at negative 1. You know, like when you're watching a movie and the music changes, you start to hear the music is changing, like if it's a scary movie. That's like a critical point in the, something's gonna happen. The music kind of changes, so think of it like that. At negative 2 and at negative 1, something's gonna happen to our graph. We call them critical values. Something's gonna happen at negative 2, something, it's like a warning. Something's gonna happen, something's gonna happen. So what I want you to do, I've created this thing called exclusion chart. I want you to draw, think of these two numbers on a number line. If you were to graph negative 2 and negative 1 on a number line, would it look something like that?
Yeah.
Okay, so now, what I want you to do, you're gonna make this chart. And you are going to put in this chart, the first few are gonna be confusing, but then you're gonna get the hang of it.
Why are we making a chart?
Because I'm gonna show you. Okay, so negative 2 and negative 1 are your critical values. Something's gonna happen here. What I want you to do is take this chart and you're gonna put x plus 2 here. You're gonna put x plus 1 here. And then you're gonna put y. Now, if I set x plus 2 equal to 0 and solve for x, where is the x value, where does this make sense? When x is what? Negative 2. So at negative 2, any number, think of a number line. What are all the numbers to the left of 0? Negative, and to the right are all positive. So if I set this equal to 0, our 0 is at negative 2. So any number to the left is negative, and all of these numbers are going to be positive.
get this chart thing, man.
Okay, just chill with me for a minute and then it'll make sense. At x plus 1, if you were to set x plus 1 equal to 0, subtract 1. So negative 1 is your 0. So to the left of 0 are negatives, and to the right are positive.
I have no idea what we're doing.
This is going to tell you, see this y value? You're going to count. How many negatives do you have in this column? 2. 2 means if it's an even number, it's going to be, if it's an even number of negatives, it's positive. So count how many negatives. You have 2, so it's positive. Count how many negatives. 1 is odd, negative. How many negatives do you have? So it's positive. So what this tells us, you'll get the hang of it. We're going to do 4 of these together. This tells us from negative infinity to negative 2, our graph is in the positive region. So here you're watching a movie, you're going along, and it says we are in the positive region. Positive means above the x-axis. Negative means below the x-axis. So from negative infinity to negative 2, you are in the positive region. But we have this asymptote here. So if you were driving along, you've got to stay, this is where you have to stay, in this region. You want to stay between here and here. That's where your little car can go. This is going to pick up negative 2. Now, from negative 2 to negative 1, here's negative 2, here's negative 1. Where are we at in the what region? What is that? Negative. So from negative 2 to negative 1, we are in the negative region.
I think that curve, the little curve.
I'm just making it up. I'm just guessing. And I'll show you in a minute. From negative 1 to positive infinity, it says where are we at? We're in the positive region. So how can I draw something that is around these asymptotes but picks this up, but stays in the positive region? So I'm guessing this is what my graph is going to look like. Now let's graph this on a calculator and let's see how close we are.
Wouldn't that just be easier to just graph it and plot the points?
Yeah, you could easily just graph it, but you're not going to understand where these numbers came from. The calculator is just going to do the work for you. You're not going to understand. I mean, yeah, I can show you, how to do it that way, but what are you learning then? That's my. Okay, so I'm going to type in x plus 2 in the numerator, and then x plus 1, and hit graph. And check this out. How close were we? Pretty darn close. Okay. So what is this right here, Andrew? What's that right there?
0, 2.
0, 2. Where do you think we got 0, 2?
From the y-intercept.
Why does it look like this graph is not coming all the way down?
Because we made the other.
We made the thing, the line.
We made that asymptote.
asymptote.
So that's important. There's some things that you don't see on this calculator that you have on here. And we did this by hand. Now, yes, was that confusing? Yes. But every time you do one, it should get easier and easier. So did I expect you to understand it completely by doing this first problem? No.
I just don't understand the little exclusive chart thing. That's
Okay,
really
well, that just tells us, based on our critical values and based on our factors, what's going to happen. Instead of us actually making, if I asked you, D'Angelo, to make a table of values, and plug in numbers to the left of -2, and you guys have a hard enough time doing the y-intercept. Could you imagine if you made a table of values and I asked you to plug in -3, -4, -5? You'd have to plug that in here, that in here, that in here. So instead of doing each one of these numbers, we're just saying in this region, we're in the negative, or we're in the positive region. So it's giving us a general idea of where we're located, not exact. Yeah, you could make a table, go ahead, make a table, if you wanna do it that way, but where would you begin? If I gave you this problem and said graph it, where would you begin? Let me show you a problem I did, last hour. Just do this. Here's one. How are you gonna know where to go? So that's why it's important to be able to do these with an exclusion chart. So with practice, we're gonna get there. Let's do number 2 together. Number 2. Okay, these are all of the objectives, or these are all of the standards, or the criteria that you have to fill out. These are what's necessary to give you this graph. So out of these 6 things, can anyone tell me one of them? You don't have to do them in any specific order. Do you know where the y-intercept is? Do you know where the holes are? Do you know where the vertical asymptotes are? The parabolic, is there a horizontal asymptote?
You said those, you said.
3, I heard 3. What's 3?
Horizontal
No.
Vertical.
What is the horizontal asymptote? That was from Friday. How do you do the horizontal asymptote?
You gotta do the x's over each other.
The degree of the numerator